Again, just a reminder to everybody. All right, we're good to go. Just a reminder to everyone, please mute your lines. Please. There's a lot of background noise out there. I'm going to try and figure out who's making the noise and mute you myself if you don't do it yourself. So please do it right now. And Allie, take it away.
All right. As I said before, the liquid manure storage structure construction inspections, it is located on your toolbox. If you want to refer to it there's a couple changes that we will be uploading after this presentation, just contact information basically. But the first topic is, how does 70-20, the stormwater rule, apply to feedlots? At this point in time, and that hasn't changed with the new rule, feedlots are not required to obtain a separate stormwater permit. For CFOs, stormwater requirements are incorporated into the MPDES permit, and for the non-CFOs, as long as you're following BMPs, you're good to go. The SDS permit is an anomaly to that. Once that permit is available, depending on the project, a stormwater permit could be required as a separate permit. And again, that's a case-by-case basis. CFOs and stormwater basics, if you're disturbing an acre or more of land, then you are required to develop a stormwater pollution potential or prevention plan, also known as a SWIP. It's required for submittal as part of the permit app. If you're disturbing more than 3 acres, so you're supposed to have it if it's more than an acre and just have it on hand. If it's more than 3 acres, you need to submit it with the application. If you're replacing existing pervious surface with 1 or more acres of impervious surface, the SWIP must contain permanent stormwater management plans, and those could include ponds, infiltration areas, filters, or a filtration of some sort. It's going to be case specific. Non-CFOs and stormwater basics, as said before, there's no change there. Previous and current practice is that you follow BMPs. They're laid out in the fact sheet, and there's no additional requirements. That goes back to the 2004 memo when they made the stormwater rules. Construction BMPs for all sites. We're hoping it's common sense. Minimize the size of the disturbed area. Don't disturb soil you don't have to. Control the tracking of the soil onto the roadways with rock construction entrances, and provide energy dissipation, riprap or bales or mulch or some sort to keep things that are leaving the site from causing erosion. Construction BMPs continued, sediment controls using a combination of buffers or silt fences, and that the silt fences are put in properly, also protecting those surface tile inlets. And if you happen to have any connection with stormwater, make sure that you're controlling that too. Make sure that you are controlling them down gradient of the feedlot parameter, and these can begin before construction activities disturb the gradient. Some examples of sediment controls. To the right, you're going to see some sandbagging type operation or the silt fence to the left. Construction beam, again, for all sites. Slope protection. No unbroken slope of a length greater than 75 feet for slopes 3 to 1 or steeper is required, and slopes not actively being worked within 200 feet of the surface must have permanent cover within the following time frame, and it's steeper than 3 to 1 is 7 days, 10 to 1 to 3 to 1, 14 days, and flatter than 10 to 1 is 21 days. Some examples of the proper way to install a silt fence. You always want to go perpendicular to flow, and you want to make sure you're creating that trench when you're installing the silt fence to make sure that it will, to the best of your ability, not just wash out when you get the force against it. CFO stormwater must follow all construction BMPs. Permanent systems required when creating 1 acre of impervious surface. This is not cumulative. It's part of the proposed project. And you must replace pervious surface to count towards the 1 acre. Replacing concrete lot with a building does not count as new impervious, and gravel roads actually do count as impervious. Permanent stormwater systems are designed to treat the first ½ inch of runoff from the new impervious surface. It does not need to collect all the runoff, just that first ½ inch. And it also does not need to be designed by a professional engineer. So if you do have a SWIP, what do you do then? Well, we're hoping that they use our form because it's pretty straightforward. You fill in the blanks, if you answer all the questions, you should be good to go. Stormwater summary would be that the CAFOs need to develop a SWIP if disturbing 1 acre, submit if more than 3 acres, and have a permanent system if the new impervious surface is 1 acre or more. And non-CAFOs just need to continue to follow those BMPs with no additional requirements. Now getting to the crux of why we're here, the construction inspections. Starting out with the pre-construction meeting. Pre-construction meetings are required, but you are not required to attend. The role of both PCA and CFOs in the pre-con is to be a bystander. You're there to answer questions. You should not be running the meeting. And notes that you would make or comments that you would make while you're there would be that we need to see those change orders, and also make sure that you mention the notices, which we will cover later, the times where they need to notice us of the staging and construction. Inspections of the LMSAs. The inspector must be a design engineer or person working under direct supervision of a PE, qualified NRCS staff, and the concrete, if it's a concrete LMSA, the person doing the testing should be ACI or MnDOT certified level 1 and 2. What you need to observe while you're out there, subgrade conditions, is it too wet, is it frozen, did the soils not look like what the borings indicated that would look, locations of the perimeter tile and the monitoring port, repairing the construction defects if they're found, and potential liner penetrations. What do we do, or what do we want them to do? Key points of when do we want to do them? Key points of construction, subgrade prep again, liner installation. You want to check footings, rebar forms. The wall pour, you want to make sure that they're putting the rebars where it needs to be and the forms are oiled properly, and we'll probably hit this a couple times. And post-construction, you want to check for defects or make sure that defects that were found are repaired. Do a construction inspection when it's required. Either we would do it if the CFO asks, the owner asks, or if their engineer, the design engineer, would request a construction inspection, we'd go out there. Also, if there's a complaint, we want to make sure we see what's going on. Rule requirements for LMSAs, construction and notification requirements. They are required to notify us if there are any changes prior to the change being implemented. They must be submitted to the PCA and approved. Notify the county or the state 3 business days prior to starting construction before a shovel goes in the ground. And we like to also know when they're pouring concrete. If there's concrete involved, it's not required. The requirements are 3 business days before start of construction and 3 days before backfill. Also, 60 days after the construction is deemed complete, we want to see those red lines or the construction inspection form from the engineer. What do we take to the inspection? Your identification, camera, boots. If you want to have any sort of marking paint or a pen to show any defects, measuring tape, and a copy of the plans. It's surprising how many times you get out there and there aren't any plans on site. What should we be aware of? Safety first is always the case. Watch out for construction equipment. If there's some big equipment being operated, make sure you make eye contact with that operator. Make sure he knows where you are. If it looks unstable, it probably is. Stay out. Do not enter the pit when beams or slats are being set. You never know what's going to happen when that's going on. Park your vehicle out of the way. Stay out of the construction crew's way to the best extent possible. If you need to see something, just have a conversation with them that you need to get in there and see something. Just a reiteration of not getting in there while they're putting in the slats. Typical construction process, excavation and what to look for. Make sure the hole looks like it's the right size. I mean, you've got the plans with you. Judgment call as to whether it's looking like it's supposed to. Water table, old building debris, tile lines that they may not have known about that they cut into. Again, conditions, is it overly wet, is it overly dry? Have they not prepped the site properly where there's big chunks of something in the middle? Sufficient room for the tile and soil removal for the footings and pump outs. Here's a definite red flag if you get out there and you see a pipe that's been cut off. You want to make sure that that's taken care of properly, capped or taken out completely. Prior to floor pouring, what to look for. Again, subgrade condition, soil removed for wall footings and pump outs. Column footings, we're going to get more specifics on that with a couple other slides, but make sure that those column footings are dug and that the reinforcement is there. Reinforcement in the footings and the floor as per plan. Forms are at least a 5-inch floor, and pump out formed and as part, the pour is supposed to be part of the floor pour. The pump out is a continuous pour. And also if there are any construction joints that they are formed properly. Here is a cross-section of a typical floor and footing, your thickened footings for the wall, and also the typical column footing for the columns. One note that I was asked by George to mention is we have had an engineer submit plans that has omitted the reinforcement of the columns as not permitted. This engineer is trying to cite an error in our checklist for construction that omitted the reinforcement. It is being fixed, and we have and always will require reinforcement under those column footings. Here's a good picture of what you should look for if you're out there before the pour, demonstrating the reinforcement and the thickened footing under the column. What to look for when you're at a floor pour, again, as we've stated, is the floor too wet, lumpy, etc.? The reinforcement is where it should be, vertical location on the floor footing, as you can see in the picture on the right. The keyway is being formed, connection to the wall and the slab or bent bar is in the right location, and that the construction pace is moving as it should. They're not trying to push it, they're doing everything they need to do, or is it moving too slow and we need to make sure that they're at least stating why there's delays in the construction. Unless you're looking for a swimming pool, this looks a little wet to be pouring concrete to me. And this is a good explanation or a good photo to look at when they have a synthetic liner or a poly liner going in. You can see where the circle is. It might be kind of hard to see, but there's a very large fold in the plastic. That is not going to give you a continuous thickness on floor. Something that needs to be mentioned and something that needs to be talked about before they get any further with that concrete.
Hey, Allie.
Yeah.
We have a question real quick. Are there recommendations for how far the soil should be excavated from concrete walls for safety? I know we don't have a requirement in the O&M, but if there's a question on that, that would be an OSHA. You could always go with the OSHA standard if you don't feel it's safe. We do not require that they submit a minimum excavation footprint. Does that help? Basically, I think so.
Okay, if there's any. So, moving on. Here's a good picture of a screed being used and a pour that seems to be moving along in the right direction. So the floor is done, now we're looking at the wall pour. What you want to look for is that the proper vertical and horizontal spacings are being met, and the proper number and type of bar. If you have any concern on the size of bar, it's basically formed into the bar on the ends. You might have to look at a couple of them from where they were cut, but that's how you can identify if it's the right number bar. That the keyway is clean, that the water stop is in place, and if you look at the rebar, there is going to be some corrosion happening, but that it doesn't look like it's too brittle, that it's meeting all standards. The wall is being formed to the correct thickness, and any construction joints that are formed are being performed as per the O&M that'll be in their operation and maintenance plan, and that any time that bar stops, there's an overlap of bar. There's no butt-to-butt joints. Here's a picture of water stop. The rebar inside the form, you can see that it's not getting too close to that back form, that it's being suspended within the concrete. Here's a good picture of the cage. You can see that, well, hopefully you can see that any of the corners are actual bends in the bar and that there's an overlap at any junction between that. Rebar spacing, that'll also be in your operation and maintenance plan. It should be what it's specified to be. If it's not, you want to make sure you stop someone on the concrete crew or the engineers out there to get that fixed. I was out at a site that had 12 specs and we actually found 19. So that was fixed by, I believe, the contractor, but if not, the owner said he was going to do it. And what they do is they can drill in and set bar in between to make sure that they're meeting that minimum spacing. Again, that the rebar is properly spaced, number and type are right, the horizontal is 2 inches from the edge, and the vertical is according to the plan. Forms are oiled and clean, vibration is being used, and that the construction pace is, again, following normal protocol, or if not, that they explain why. Picture of the wall pour, you can see that the concrete is being pumped in and they're finishing as they go, and this guy looks like he is running the vibration to make sure that it's getting in there and it's a consistent cure, an existent pour. When you're looking at the perimeter tile, you want to see placement 1 foot horizontal from the footing and below the floor level. The sump or daylight is where that the water can flow to. It doesn't look like there's any elevation concerns. Dedication to the monitoring port. The type of envelope material looks clean. It looks like it meets the specification for envelope. Around all sides of the barn, and if there's any damage during construction, that is fixed. And if it's pre-tiled, you want to just make note that it was done before so that you didn't get a chance to look at it. A picture of tile install. It's coming out. Hopefully this is just during construction, but if this was, it could be that they ran into an existing tile. You want to make sure that that is either drawn into the new tile properly or that that junction is taken care of. Picture of the monitoring port. Going on to the columns, beams, and slats. Again, what you're looking for is the consistent with design. Are they doing the type of column that they stated in the plan? Do they have the extra rebar in the beam pockets? Are there at least 3 beams that touch or are grouted? The first 3 beams are touch or are grouted, and that the slats rest securely on the ledge and splicing falls securely into the beams.
Hey, Allie?
Yes.
We have another question. Can you go back a couple slides to where they have the tile going around the pump out?
Yes. Oh, I think I can. I'm going the wrong way.
Going the wrong way.
What? Okay, yes.
Okay, so the question is it okay that when the tile goes around the pump out like that, is it okay for it to be within that foot around the pump out?
It is okay. It's not ideal. We'd like to see it outside. We do have some engineers that actually do them under the pump out, which we discourage from. But it's not technically looked upon as storage, so if it's within that foot, we're okay with it.
All right. Thanks, Allie.
No problem. Now if I can find where I stopped going the wrong way. All right, so here's an illustration or picture of the rebar getting set for the column pour. You can see the sonotubes out by the grain bins there. And these are, here's another picture of a a successful beam setting. Other items to look for: the engineer or the inspector for the engineer out on site, were cylinders being poured, air, temp, and slump being taken, how many trucks had visited the site, are there enough crew members to keep up, are they falling behind, how long have those trucks been there, is water being added to the concrete? If that is the case, it should show up on the ticket. If you see that water is being added, you want to make sure that the ticket from that truck states how much water was added. And that could reflect on your cylinder brakes, so it's good to know. And it needs to be there for documentation of the construction. You might not need to receive that, it just needs to be documented. Is the concrete truck washout area there? Is it located? Are they using it? And other practices, does it seem like it's going well? I mean, just check it out. Is the construction site seeming to function the way it should be? A little background on concrete testing. Cylinders should be cast at least every 150 cubic yards, I believe. Most specs I see are every 100. And if they get a new supplier, if there's any change in the type of concrete, new supplier, new mix, they need to also do a set at that time. Cylinders are cast in threes normally. They are cured in place for at least a day. First breaks are done at 7 days. And if the concrete meets the prescribed compression loading, then often 14-day breaks aren't needed. Sometimes they get them anyway, but usually there's a 7 and a 14-day break. Once they get to the lab, they're cured there before the breaks happen. And then there might be a 21-day break if there's still something going on with that concrete. Slump is also required to be taken at the same interval as the cylinders are cast. Basically, 3 lifts are put in, just like in the cylinders, into the cone. You lift straight up and see how much distance, if the concrete moves down, slump is the term. And that's going to tell you your water content, if it's going to set up, how runny it really is. And that's important for curing. You can also see in the picture of the already foamed concrete that temperature is taken. That also tells a lot about how that concrete is going to react when it's in place. Air content is recommended to be done. If air entrainment is prescribed or is required in the mix, I would suggest doing an air pot test. Post-construction defects and repair. Honeycombing is one of the common ones we see. If there is a defect, you want to remove all the loose stones and spread grout over the affected area. Why we want it fixed? It's structurally, those impaired areas aren't going to hold up as well structurally. You want to protect that steel. If air can get to that reinforcement, it's going to corrode more. And we also want to protect against leakage. Here's a nice picture of honeycombing. Honeycombing in columns. It doesn't just happen on the wall or the floor. This is at the junction where we see it a lot of times. If you're going to see honeycombing, it's going to be where that hole joint is between the floor and the wall. Here's some pictures of a grout fix and an epoxy fix.
Hey, Allie.
Also, yeah.
Before we move on with cracks, just one more quick question that came in. Talking about rebar in the floor, can you maybe explain, where the rebar is required to be in the floor and why we don't require rebar all throughout the floor with the fiber mesh, et cetera, et cetera? Or we can bring that up later too if you want.
We can do it now, that's fine. So it depends on the engineer's spec. We can, as long as the fiber is prescribed in the concrete mix itself and it meets our standard, which is in the checklist, I can try to pull that up at the end if we want. We are not requiring it throughout the floor. I have seen where they do. It depends on the preference of the engineer, really. we do require the reinforcement always in the columns, footings, and in the floor footing. So it's basically a requirement in the type of concrete and the load that it's going to be taking. If someone needs more specifics on that, I can sure go in that direction.
Okay. Yeah, so it's always required in the walls.
Yep, and the columns.
If they have the fiber mesh prescribed in the floor,
yep,
we allow that in place of rebar.
Correct.
Okay. All right, I think that will answer the question. Proceed.
Okay, and moving on to everyone's favorite, the crack check out there. If cracks do occur, we want them repaired with a crack sealant compound or a grout. Again, if there's some feathering or veining in the crack, you want to make sure you take out anything that's loose before you do that sealant or grout over. And again, it's to protect against leaks, and it's also to protect that steel. We don't want corrosion happening in that support. Some pictures of cracks that need to be fixed and the subsequent fix that happened. There's epoxy and grout. Post-construction defects and repair, so exposed rebar. Again, we're going to either apply a sealant compound or a grout over for the same reasons, structurally to protect that steel and against leakage. The column rebar. Another fun one that I have not experienced as much as I think Toby and George have, but mudballs. The repair would be to patch with new concrete, only if they occur in very isolated areas only a few times. We have required up to a 3-inch overlay over the affected area if they seem to be consistent in any area of the pit. And same importance, leakage, protection of steel. Also with this, we need to ensure that there's at least 5-inch thickness for floor. That's a good one. And you can see all of these kind of wet areas here that they look like they haven't cured yet. That's just mud mixed in with the concrete that has kept it from curing properly. And you can see this is the forming that is happening to do a 3-inch overlay. Some more mudballs. Mudballs by the keyway. This is a fun one. This rebar was thrown in, and if Sarah's on, or if anyone that was out on this site is on, you can correct me if I'm wrong, but I think I was out there about a week after this was poured, and you could throw that rebar and it went right through. It didn't resist at all. So here is a example of what a overlay submittal or amendment to the plans would look like, what we would require. Other post-construction defects and repairs, unauthorized penetration or defect, what we would require is that you plug it with new concrete, drill in some bar to make sure that you've got the proper structural stability, and then patch that hole. Again, to protect against leaks, and it is prohibited except for where you're transferring manure to manure, or to another manure structure. Beam spacing and alignment, what we would require is you to move the beams or grout the joints to make sure that there is connection, that those first 3 beam segments are grouted or touch to make sure that we're supporting that floor properly. That would be one that would need to be moved or fixed. We also do not allow patio blocks to be used as shims to make sure that the floor is level. In this case, they used hollow cinder blocks for these pillars or supports. When it comes to Weiser manure storage structures, we want to be aware of the pre-construction. We want to make sure that we are all on the same page before these go in. A Minnesota engineer has to stamp these plans. There has to be a Minnesota licensed engineer to sign them. A Pan-L build system is allowed. The L panel system is not okay. And the full spec book must be included. A Type 3 floor is often proposed, or that it is proposed that we make sure a Type 3 floor is being spec'd out. Soil borings have been done, and perimeter tile is needed and addressed. Typically by a third party, they're put in. During construction on a Weiser, a Type 3 floor was installed. The water stop is placed at the joints of the wall panels. We're still kind of debating on the need for a wall floor joint, but that the perimeter tile is installed, and again, normally that will be done by a third party. Getting into earthen basins, we want to make sure that there is protection to the liner, that the concrete pump outs are a 16-foot minimum, concrete pads are 20 foot by 20 foot, and a sump design is best. This is why there's a concern to having those pump outs be constructed properly. We've got some serious liner disturbance here. And again, we've seen sinkhole or holes that have been agitated out of the liner. What is our role, either county or PCA, when we're out on these inspections? Basically, we're just there to check the checker. Technically, we're not required by rule to be out on the sites, but to be out there at least once is recommended to help find any fixes that might have to occur or any anomalies that happen, to make sure that any changes that have been made have been cleared and are approved before they're using these structures. And also, it's the easiest place to make the fix happen. It's much easier to fix it before it goes into use. When can the LMSA be used? As soon as the structure is completed. There's no need to wait for PCA or county approval. We do have to have the proper notices. If we have not been noticed, again, 3 days before dig, 3 days before backfill, and concrete notification is nice, then there's no reason to wait. If you have to handle a major problem, typically the engineer is willing to fix. I haven't had very many instances where if there was an issue, the engineer has done anything but said, we'll take care of it, we're moving forward. We do need any major changes to be approved by the state and or the county. If the construction report is not adequate, we may need to remove the concrete for additional inspection. It actually has happened where we've made them clean it out and take a look. If you have questions, should you stop the construction process? That's rarely needed. Give us a call, give Kim, Toby, George, or I a call. Fixes usually can be done later. It's just much easier and less costly to do before. Other technical items, finished for guidance. The concrete pit review checklist is done. We do have that fix that's in the works on making sure that we clarify the specification of column footing reinforcement, and the pit design guidance document is out. The earthen basin design document is nearing completion, and we should have a new checklist and construction guidance handbook done shortly. With the rule going into effect, we had a few things that needed to change. So hang tight, it's on its way. And if you have any questions, as I said earlier, George, Toby, Kim, or I are more than willing to work with you guys on them. Does anyone have any other questions?
Yeah, Allie, we had one more question come in towards the end. Discussing the pump out pads on earthen basins. Is there curbing needed on the pad as well as the ramps themselves? Or is it just on, well, just discuss curbing? the pump outs and pads.
Yeah, it's not required. It is encouraged. If they want to do it, that'd be great, but it's not required. We do want to see there be some, like a sump design, that there's flow down to where they're going to be agitating, but curbing specifically is not required.
Okay. Are there any other questions for Allie regarding construction inspections, design of LMSAs, et cetera, et cetera? Now's the time. Well, everybody can think about that if they have any questions. Allie is actually going to be giving another quick presentation about some of the liquid manure storage areas, the smaller ones, and the design standards and what we need to be looking for those smaller, what are they called, limited risk LMSAs?
Yep.
Okay, and oh, we do have one more question regarding the Weiser pits, I believe.
Yep.
What is a type 3 floor?
I can get you guys that. It's basically it's the standards. I don't think it's much different than a normal floor. We just want to make sure that they call out that it's a type 3, that they're doing the reinforcement under where that wall is going to be, and that they are meeting standard for the concrete, because those panels come in precast. So we don't want the floor to be precast as well. We want to make sure they're calling out a type 3 floor. I can get them, we can email out that standard so that you have all the verbiage if you need it.
Okay. Sounds good. Let's go ahead and move on to your next presentation. Again,
right.
Feel free to shoot me questions, and as Ellie said, she doesn't mind being interrupted. So we will let you go. Take it away.
All right. So George had presented this at the Owatonna regional meeting. I'm not sure if it was discussed at the others, so we're just going to hit it again. As part of the rulemaking, we added a definition for an area where liquid animal manure and processed waters are stored or processed is an LMSA. There was not a technical definition for LMSA. What that means is if liquid manure, if it can't meet the stockpiling standard, if you can't stack it, it's liquid. LMSAs now include, because of this definition needing to be clarified, settling basins, reception tapes, wedge pits, stacking slabs, day pits, anything that holds manure consistently may now fall into the LMSA definition. The exemption to that, well, there's two: temporary storage or processing, and settling basins. Still considered LMSAs for permit requirements. It's not a free pass. The permit conditions may require more information. It doesn't mean that we can't require more. It just means that if it meets all of the exemptions, they could fall out of the LMSA definition. It's kind of circulating back on itself a lot. But there's limited submittal required for approval. So temporary LMSA exemption is only for temporary storage or processing. Reception tanks for runoff, manure handling, solid separation, sand lanes. Concrete construction only. It's only for concrete structures poured or precast, and the volume limit at 20,000 gallons. In a karst area that falls lower, it falls to a 5,000 gallon limit unless there's 5 feet of separation to bedrock, and that should be proved through borings or any means necessary to prove that separation if you want to go above that 5,000 gallons. The designs and plans are still required, but a professional engineer's signature is not. 5-inch floor and water stop is still required. Concrete specs are still all required. No non-manure transfer liner penetrations are acceptable. You can penetrate that liner. And seasonal water table you're still needing to meet the distance to water table based on the soil survey, and you still do need to have an operation and maintenance plan. The settling basin exemption for an LMSA is the settling basin used in vegetation treatment system as an example. The overall system must meet the NRCS 635 standard, level 4 or 5, and if that's something you guys want clarification on, I can get that to you as well, or you can look it up. It must be emptied within 24 hours. The constructed floor must be concrete or a cohesive soil like a basin would be required to meet. It must have 2 feet separation to bedrock if it's soil only. The design plan is required, but no PE signature would be required to that plan, but you still are required, as always, to have an O&M plan, a site plan, and that site plan must include a description as to how you're going to maintain it, how you're going to meet that timeline of storage. And that's it. That's a short down and dirty on the limited risk. Back to you, Ben.
Okay. Are there any questions for Allie regarding the limited risk? I know it's fairly new, so there may be some questions. And that will, I'm just reading one question that's coming in now. Can we get the PowerPoint email of the LMSA exemption stuff? We will put this presentation, the Webex is being recorded, and we will put that on our website. And I will actually send it out right away, because once the Webex gets done, sends me an email right away, and I'll forward that email on to you guys right away. So that will be available then, but I will check with Forrest. I think, well, we should probably make sure the tech team is okay with us putting it up on the website as well, but I think we can probably do that. Right, Allie?
Yeah, I don't see any problem. I'll talk to George about how he wants to, it might need some just finalization if he wants a title on it or something like that. We'll do that. I know Ben and I had talked about updating the few things that updated on the concrete inspection too. So they'll be coming shortly, and we should be able to get this on there too. There'll be a fact sheet, I'm sure, that'll go along with this, and make sure that if you do have one of these types of basins coming in, that you talk with your regional staff or one of us for engineers, because it is new and there's going to be some learning pains, and we can always request more information. We always have that right. But if it does meet all these requirements, then they're ready to go. I'd just rather have more information than wonder later.
Right. So we do have a couple questions that have come in. Are sand lanes looked at as an LMSA?
They meet the definition, but they should meet the exemption. That's where it's kind of cyclical. So we're gonna wanna just check it out, make sure that that works out. So yeah, so it's temporary storage. It's used for conveyance. It's not used for storage. I guess that's one of the big things. If it's conveying and not holding, that's where we have some exemption leeway and the volume. But
and are all of these limited risk or temporary storages, do they still need to meet LMSA standards?
Yes.
Other than the design engineer's sign off?
Correct.
Okay. All right, so it says another question is, when you find a limited risk LMSA that needs corrections, do you need an engineer involved then?
Depends on what the fix entails. Unfortunately, our standard, it depends. If their fix can fall under all the exemption requirements, I would monitor it. I would potentially either an interim or a modification depending on the size of the operation. It's going to be site specific. If it meets all the exemption limitations, you may not need an engineer to fix it.
Okay. This is is a longer question. I've had some LMSA owners tell me that at the time of inspection that the agitation pads are not being used because the pumping equipment used by their pumper is too big. It does not fit on the pad. How do we handle that? That goes back to the pump out pads from your previous presentation.
Yep. That's, unfortunately, you're limited as, I mean, they can go in if it's empty and try to make the pad bigger. It's going to be, in my opinion, it's going to be a discussion between the owner and the pumper. They're kind of limited to what they have. I don't know, I can open it up to others if anyone else has anything to add to that. I mean, they could try to do an addition to it, but that's going to be pretty intensive, and we're going to want to see how they're going to do that. We're going to want to see some sort of description as to how they plan to increase their pad size.
Let's see. That was Lori that asked that question. Lori, maybe you just want to unmute and maybe explain your situation a little bit more and give us a little more information to be able to try and help you out a little bit more, if that's okay. Lori, are you still there?
I'm here. You got me now?
Yeah. Yep. We got you now.
Okay. All right. Yeah. No. Yeah. Dairy operation. On the time of the most recent inspection this past spring, he stated that the pumpers weren't getting complaining that the pads were too small and they slid off with their equipment and it was wrecking their tires or whatever. So, you know, there's concern about how it's affecting the liner. I was just wondering whether that's if they know that that's happening. I mean, is that some type of a violation that we should address, or we encourage them to talk to their, you know, their company they're using, or, you know, can we require them to increase the size of their pad, or how do we handle that, I guess?
Yeah, I mean, unfortunately, it is what it is now. I mean, the basin is intact. I would encourage them to discuss it with their pumper. Maybe they could try getting closer. Is it a concrete, do they have a chute, or is it just, it does have a ramp, correct?
Yeah, it does.
Yeah, so I mean, maybe getting closer to the ramp, it's kind of hard on it, but I mean, at least then when you're spinning against more concrete. I don't think we can require them to increase the pad. The problem is if the liner does get breached, they are in violation, and we have to go through the enforcement at that point. So it's one of those catch-22s where the first place I'd start, like you already mentioned, is have them talk to their contracted pumper and see if they have any other equipment they could bring out. And in future construction, maybe have the owner discuss with who they're going to contract with on the equipment they have. I mean, the equipment's getting bigger too, and these older basins might have smaller pads. So that's one conversation. It won't help the existing site, but future sites might want to have a conversation with who they're going to have pumped to make sure that what they're installing is going to work with the equipment that's going to be used on that site.
Right. All right. Yeah, I was curious whether, you know, there was any. I
don't think we can require, if it was built as per spec, and I don't think we can require them to increase it. They can. We would just want to see some plans as to how they're doing it to make sure that they were getting a good joint between the cold pour and the new pour. So.
Right. All right. That covers it. Thanks.
Yep.
Okay. Any other questions for Allie right now? All right, so one question is, how many days after the floor pour can it be walked on to inspect? Do you have any?
Next day? Yeah, I mean, you can get on it the next day. you want to see how it's curing. I mean, if you see that there's kind of a slick on top, you want to best professional judgment that, but it should be fine the next day.
Yeah, I was going to say typically 24 hours.
I mean,
usually enough to have it set up enough to walk on it. But yeah, I mean, if it's looking really green when you're out there, I would tread lightly and use your best professional judgment. Yeah, so we don't have any other questions right now. Oh, another one came on. Okay, so the question, I guess basically the question was regarding how long after they finish the floor do they typically begin framing for the walls?
And I'd say it's pretty much the same question, next day. I mean, they're going to be, barring any other requirements by the contractor, they're going to want to be forming as soon as they can. They're going to be tying into those bars they set as they were going on the floor, and they're going to get going, usually the next day.
And just to be clear, I'm guessing, next day they're probably not going to want skid loaders hauling forms around on the floor the next day.
Right.
But,
yep.
They can certainly.
But they're going to at least start tying their cage, their rebar, and they might be moving in some forms.
Sure. Because it's what, 28 days for a full cure on it?
Mm-hmm.
Concrete usually.
Right around there. That's why they're not wanting to have backfilling before the slats are set.
Right.
Complete backfill. For stability and making sure that cure happens with proper support.
Yep. All right. I guess, thank you, Allie. We'll just stay on for a couple more minutes here. Are there any other questions for Allie, or honestly any other questions about really anything? We have a few minutes here that if there's a burning topic or a burning question that you have related to construction, not related to construction, now's an opportunity to try and get some answers if you would like. Another quick question, Allie, you can probably answer this too. Is access to inspect the floor usually fairly easy, or is a ladder sometimes needed? My guess is that's probably how far along they are with setting up the rebar and or forms.
Yeah, very oftentimes we get out to check the floor and wall, and if the wall's already up, then there's been times where I've set up the ladder, and hopefully there's another person there to help me flip it over and get in. So it depends on what stage of construction they're at, but yeah, it is common to need a ladder. You can get in through the pump out too. I mean, if they have done slats and they're already done, it's not the best situation, but it does happen.
Yeah, typically you're going to want to, the best time probably to get there is after they've poured the wall and removed the forms and before they backfill. So
right.
Oftentimes you're going to need a ladder if you want to get into the pit, but sometimes you can shimmy up the form dies if you're feeling lucky, but again, safety first. Right.
OSHA's not real pleased with that, but I'm not going to be able to tell you it hasn't happened.
Right. And I mean, I don't know, maybe you want to talk about it. If you are there during the pour, I mean, maybe try and find the inspector just to make sure that they're there.
Yep. Yeah, and a lot of times I try to get a hold of the engineer and the owner before I go out there if I have the time to do that with when I'm notified that construction's commencing or that they're going to be, walls done, they're going to be setting slats the next day. You try to get a hold of people to let them know you're going to be out there. And when you're out on site, you're not all by yourself. You want to know who's out there. have a conversation if there's anyone else out on that site to let them know why you're there and ask any questions you have of what's going on.
Right, right. And again, like Allie said before, it is definitely the engineer/inspector's responsibility to make sure that the construction is completed per the plans and specs. However, it's still important that we get out there and take a look at it. In my experience, and you guys at the county have a great opportunity. You're typically closer. You can get there more often, maybe a couple times during the process. But if you go out there and you find some honeycombing and you find some cracks, you'll find that your engineers and inspectors are going to make sure that they're out there when they need to be and looking at that stuff as soon as possible to make sure that they're finding it before you and or around the same time as you. It does wonders for just accountability. If they know you're out there, they're going to make sure that they're out there doing what they're supposed to do.
Yeah, and coupled with that, oh, sorry, go ahead, Ben.
I was just going to say anything to add to that, and you were on already.
If you do find anything, make sure you have a camera with you. Email that engineer what you saw. I mean, I have conversations with them often, you know, looks good, I saw, doesn't look like anything major, but, you know, the northwest corner looked like there was some potential going on, take a look, or there was an oddity running northwest, or north-south on the floor. It doesn't look like a crack, but there's a different coloration. Just have that conversation with that engineer. Let him know that you saw it. I mean, it might not be anything he feels that needs to be addressed, but at least then you're having that conversation. It doesn't come up later that it wasn't seen when the engineer was out there and things progressed and it got missed. You just want to make sure you have an open conversation about what's going on and what you saw. So.
Okay. Yeah. Sorry about that. Any other questions?
Are we done?
All right. Hearing none, thank you all for your time. Thank you, Allie, for presenting. Much appreciated. And everybody have a great rest of the week and great rest of the summer. We will, I'll be sending some invites for regional trainings coming up in August, and we'll hopefully see you in person then. Take care, everyone.